Today's notes are on cellular energy, or what we commonly refer to as ATP. ATP is adenosine triphosphate. It's a molecule where the energy used by the cell is stored. As you can see, we have a molecule here, which we refer to as adenosine, and we have triphosphate here. Tri means three, so there are three phosphate molecules in adenosine triphosphate. And again, this is the molecule where the energy is stored to be used by the cell for cellular work. Adenosine diphosphate, di meaning two, right, is going to have adenosine molecule here with only two phosphate molecules. And this molecule is created when the phosphate is removed from ATP and energy is released into the cell. So when one of these phosphate molecules on the adenosine triphosphate breaks apart, it lets one of the phosphate molecules go as well as energy. And as you can see, there's only two phosphate molecules left. Energy is stored in the bonds between the phosphate groups. So energy can be found between phosphate molecules here and here. Once the phosphate is released by water, the bond is broken and energy is released, and then ADP is created. Here's an animation that shows what's happening. Go ahead and watch. Again, we have an ATP molecule with high energy bonds. It's going to be broken with water. Once it's broken, the molecule becomes ADP with two phosphate molecules. Energy is released, and the third phosphate molecule is hanging out. So again, let's watch it one more time. We have ATP, three phosphates. The bond is broken with water. A phosphate is released as well as energy that's going to be used for the cell. So here we have the ATP ADP cycle. What you're going to need to do here is you're going to need to draw this cycle as well as write down what is happening. So I'll give you a minute to draw that down, and then we will go ahead and talk about what this cycle means. We're going to start here at ATP. Again, T stands for tri, so there are three phosphates here, adenosine triphosphate, three phosphates. What's going to happen is when water is introduced to that phosphate bond, it will break, allowing energy to be used for cellular work, right? So here we're following the arrows. Water is entered into the ATP molecule, it breaks the bond, and then energy is released for the cell to use. And what happens, what's left over, is we have ADP and P, which stands for phosphate. So we have adenosine diphosphate, there are two phosphates here, and the leftover phosphate that came from the triphosphate up here. And what happens is when we eat food, we gather energy from that food, and those two molecules here combine again to give us ATP. ATP is important because it stores the energy for when our body needs to be able to use that energy to do work. But in order to use that energy, it has to be released, and it does that by water breaking the bond. Now I'd like you to complete your summary and questions.